Before we begin, I would like to briefly highlight an exciting development for our lab. MindSpec is expanding its research collaboration network with experts from leading organizations and institutions, including Quick Hill and Squad, Karlsruhe Institute of Technology (KIT), Infosys Cybersecurity, and the University of Michigan Flint. These collaborations aim to strengthen our work in AI, cybersecurity, privacy, software engineering, and applied research by bridging academic research with real-world industry challenges. As part of this vision, our reading session series serves as a platform for exploring cutting-edge research and fostering meaningful technical discussions. Today, we are pleased to have Soham Paul as our presenter. Soham is currently pursuing his master's degree in computer science and engineering at IIIT Guwahati, while also working as TCS as a generative AI developer. His expertise spans machine learning, deep learning, NLP, transformers, RAGs, LLMs, explainable AI, and federated learning, with a strong understanding of the underlying mathematics and statistics. At TCS, he contributes to building scalable generative AI and agentic AI solutions for real-world applications. Today, he will be presenting the paper Plan and Solve Prompting: Improving Zero Short Chain of Thought Reasoning by Large Language Models, which introduces a planning-based prompting strategy to improve reasoning performance in large language models. So let's welcome him for today's session.
Is there any technical problem to join by the speaker?
Hello.
Yeah, yeah. Okay, okay.
So, shall I start?
Yeah, yeah. You can start.
One second. Is it visible?
Yes, it's visible.
Fine. So, good afternoon, everyone. Before I start discussing or going directly into the presentation, I'll provide a short brief of the paper that I'm going to discuss. So, the paper generally starts from a very practical observation about large language models. Large language models can often answer easy questions, but they become unreliable when a problem needs several steps. Any kind of a complex problem, for example, you can take any mathematical problem that is a bit complex. So, the authors argue that the model is not always ignorant. The model has the knowledge, but sometimes it simply forgets a step or slips in a calculation. So instead of asking it to jump straight into solving, they ask it to first build a small plan, and that is the whole contribution of this paper. The research gap of this paper would be pretty easy. So it's zero shot chain of thought removes the need of examples. This is what is said by the authors. So what authors wanted to say that zero shot chain of thought removes the need for examples, but it still does not force the model to structure its thinking well enough. The paper's objective is to make zero-shot reasoning more reliable without retraining the models or without providing additional manual examples, like what happens in one-shot or few-shot learning. So they are introducing Plan and Solve and Plan and Solve Plus. The main contributions I would like to say is they identify the main failure modes of zero-shot chain of thought prompting first. Then they propose plan and solve, which explicitly asks for a plan before solving, and propose a plan and solve plus, which adds a more detailed guidance. And finally, they show that this simple prompt change works across math, common sense, and symbolic reasoning tasks, because they're asking the model to plan before solving, starting directly to solve a complex problem. So now I'll start with the presentation. So like I said, this paper is about improving how large language models reason. The authors focus on a simple but powerful idea that instead of directly asking the model to answer, the model should plan it out first, and then it can proceed step by step for executing the plan. The reason is that this matters is many reasoning failures happen not because the model knows nothing, but because it skips structure while solving. Uh, this slide introduces chain of thought prompting. The key idea is that if we show the model step-by-step examples, it learns to generate reasoning steps instead of only giving the final answer. This usually improves accuracy, but the downside is very obvious. Someone has to manually write those examples, and that it is slow and costly. Otherwise, we have to retrain the model where we feed the model with examples so that directly upon a prompt, the model can start. So it is again very costly. This slide shows the problem with zero-shot chain of thought. So zero-shot chain of thought tries to remove that manual effort. Instead of giving examples, we simply add a sentence like, let's think step by step. And this works surprisingly well because this triggers the model to have a plan in mind. So we first ask for that plan. But the authors here ask an important question, that is this one sentence really enough for solving harder problems? So here, to answer that question, the authors looked at where zero-shot chain of thought is failing. They tested 100 arithmetic problems and inspected the wrong answers, 46 answers that came back wrong. So they found three main failure types. First one was calculation mistakes, second one was missing steps, and third one was semantic misunderstanding, which was the most effective one. This important takeaway is that many failures, like I said, it is not like the model is not understanding or model lacks knowledge. It's simply skipping some steps because of forgetful memory. These were process failures. So, and then this slide states that the main research question is very clearly, very clear. If the problem is skipped, this analogy with how a human thinks. The authors compared the idea to how humans solve hard problems. So we usually first, like if we get a complex problem or a math statement, we first try to understand the problem, break it in parts, then solve each part, and finally then come out with the answer. So the paper argues that LLM should be encouraged to follow a similar pattern. This is the main intervention of the paper, plan and solve, or PS. Instead of saying only think step by step, the prompt now says, first understand the problem, devise a plan, then execute the plan. The big advantage is that this needs no retraining and no example demonstrations. It's like asking an agent who has a proper domain knowledge that I don't understand this problem. Then you ask the agent to create a plan, then execute the plan. The model receives the question, then it creates a plan, then it executes the subtasks, and finally it generates the answer. The idea is that if the plan is written down, the model is less likely to silently skip an important step. This is because the model then will have a proper task created, and it will divide the complex problems into subproblems, which it will have in memory. And so they will be executed like processes, step by step, and the model will not forget. Why stop at planning? Because planning helped, but it did not solve everything. The authors noticed that some arithmetic slips and variable, how to say, like the problem was arithmetic problems and variable related mistakes still remained. So they pushed the idea further and asked how to make the prompt more disciplined. So they tried to improve the prompt, not the model. So then they introduced Plan and Solve Plus. PS Plus is the stronger version. It adds explicit instructions to extract relevant variables, then make a complete plan and calculate intermediate values. Then it pays attention to correctness. In other words, it does not just ask the model to plan. It tells the model what a good plan should include. So this slide compares the PS and PS Plus. This slide, the chain of thought asks for step-by-step reasoning. PS adds an explicit plan, and PS Plus adds variable extractions and intermediate calculations too. So each version adds more structure than the previous one. The chain of thought actually will not prompt the model to devise a plan. PS does it, but sometimes the answers are not correct. So PS devises a plan and asks the model to extract important keywords or important variables from the prompt itself, so that the model has its memory updated. Now the paper explains how the experiments were done. The authors used GPT-3 with the text DaVinci 003 engine, greedy decoding, and 10 benchmark datasets covering arithmetic, common sense, and symbolic reasoning problems. This made the comparison fair because the same backbone model is used across methods. This slide lists the baselines. They compared against zero-shot chain of thought, zero-shot plan of thought, manual few-shot chain of thought, and auto chain of thought. So the paper is not just comparing against one weak baseline, it compares against several strong and widely used prompting approaches to prove that yes, that technique is improving actually. On arithmetic tasks, Plan and Solve, and especially Plan and Solve Plus do well. This is what the authors provided in the results. The important point is not the exact number, but the trend. So Plan and Solve beats plain zero-shot chain of thought, and PS Plus beats both. That means changing the prompt or rewriting the prompt is actually doing the real work. On common sense reasoning, PS Plus still improves over zero-shot chain of thought, although it does not always beat handwritten few-shot prompting. So the method helps beyond mathematics, but it is not a magic solution for every task. So this is one research gap that I found. On symbolic reasoning, PS Plus is especially strong. For one task, it even beats the few-shot baseline. And few-shot means you provide the model multiple examples. So the model actually has a strong grasp on what we are trying to say. So PS Plus even bet that baseline too. And on the coin flip task, it is almost tied with it. This shows that the planning idea can work very well when the task is more structured. The authors have also tested self-consistency, which means generating several reasoning chains and taking the majority answers. So that PS Plus with self-consistency performs even better, showing that PS is compatible with other reasoning improvements rather than just replacing them. This slide explains why PS Plus works. When the authors rechecked the wrong answers, they found that PS plus has reduced calculation errors and missing step errors the most. Chain of thought had the highest in these things, in miscalculations or missing steps. PS had a few, but PS plus improved drastically. Semantic misunderstanding, however, they did not change much, which suggests that planning helps organize reasoning, but it cannot fully fix poor comprehension on the question. So this is another research gap. Here they go one deeper level. They check whether the generated output actually contains a variable list, a plan, and a solution. The result is that having a clear plan is strongly linked with fewer missing step errors. So the structure of the prompt really affects the structure of the model's reasoning. The main insight here is very simple. Better structure gives better reasoning. It's all about the prompt. The model becomes very less likely to skip steps or make careless slips when it is explicitly guided to organize its thoughts. This one summarizes the strengths and limitations. The method is very simple. First, the model needs no retraining and works with zero-shot examples. But prompt wording still matters, and semantic misunderstanding remains a difficult problem. Like I said, this was the second research gap. So the method is telling us about the future directions. The authors suggesting that better planning strategies, self-correction, multi-agent planning, retrieval, and tool use. So they are trying to focus on agenting systems now. In a broader sense, this paper is part of the same idea behind many modern agent systems. Plan first, then act. This is what agentic AI does. So the final slide, the final takeaway is pretty straightforward. Zero-shot chain of thought asks the model to think, while plan and solve asks it to plan first and then think more carefully. Whereas plan and solve plus adds extra discipline by asking for variables and intermediate calculations. That small prompt change closes a lot of the gap to more manual prompting methods. So this paper came out in 2023 at the time when people were researching very much about types of prompting. Prompt engineering was a huge jargon that time. So I chose this paper because nowadays too, whenever we are vibe coding, we use this to get an idea, then actually tell the model to give a proper prompt, so that when pasted on some other LLM or in that same model, we get the exact accurate results. So that is why if you give a prompt like that, you'll see the now mostly LLMs like GPT, whatever the chatbots we use, they have converted themselves completely into agentic AI. So you can see how the agent there, after you give the prompt, plans and then decodes, then it goes through several processing steps, and then finally the model outputs a very detailed prompt that can help you to get what you want. So this is what I found pretty interesting in this paper. That's it.
Thank you, Shoham. Uh, on behalf of the other listener over here, I'm just raising some few questions, and that might be clarifying in better way that what exactly you are telling. You are telling in that context. It would be. My question is that, could you clarify a little bit of like this 2 to 3 basic jargons which is actually being used into this particular slide in the presentation, that is zero shot, few shot. What is the difference, and with them some example if you just
Sure.
that one.
So if you guys study prompt engineering or have come across this term, you might have known what is zero shot prompting or few shot prompting. The thing is, if someone does vibe coding or someone has a very little knowledge, then he simply asks the model, like for example, if you are trying to build a, a model on a traditional machine learning algorithm, you just go and ask the model any question, just a simple question or query. You can consider it as a zero shot prompt. One shot prompt or few short prompts is something which we know how to solve the problem, but actually we are trying it since it's complex, we are telling the model to do it. Now zero shot or few shot is something like zero shot, sorry, one shot or few shot is we give the problem statement and also give a few examples how the model should solve it. For example, if you are giving an arithmetic problem, then you give a actual real life example with it. If you give one example, like add this number to this number, then divide it, and then you get the final answer. So this one example you gave along with your query, this is considered as one shot prompt. Few shot means if you know the problem is much more complex, then you give more than one examples. That is how the model understands that okay, this is the proper way to solving the problem, and I must follow these steps itself, and that is how the model answers your query.
So in this context, I think it is better to know, I mean,
Yes.
how this one shot or few shot uh,
Yes.
is related to the chain of thoughts. What exactly you mean by the chain of thought and few shot? You are telling that the few shot means some particular examples you are actually providing, and
Yes.
you are making
Yes.
the model aware that what exactly the question, if it is actually getting, then how to solve this particular with some examples. We are actually giving some examples to make it more conventional reasoning method to develop over there, so that it can answer your question. That is what actually the few shot. Then how the
Yes.
chain of thought works over here, and chain of thought came into this existence.
Chain of thought is something like you are giving the model a complex query to solve, but you know the model might make mistakes. So you are telling the model that please go to through the query, you try to solve it, but intermediately you show me the process how you solved, you show me the steps how you solved. In that way you get an idea that this is how the model is taking decisions. You can also see where the model might fail if it has not given a proper answer or has done some miscalculations. So you can see an indirect way how the model processes and tries to conclude an answer. So this is how chain of thought happens. It's
Uh,
like one thought leads yeah.
that means, are you telling that the chain of thoughts is also correctional?
Yes.
Means, let's say, for example, in which direction the model needs to think.
Hmm.
If it is thinking in a wrong direction, reasoning in a wrong direction,
Yes.
might be corrected by the manual intervention,
Yes.
right? So that means
Right.
chain of thought process is a time consuming, and also it's costlier, because the human interventions are actually over
It
there.
is not entirely costly. We are just seeing how the model is planning to solve.
No, I'm basically telling the costlier from the perspective that as it is the human interventions are actually over there,
Human,
right?
yeah. If you are
So
if you are
if you are actually going for one particular means, one particular human intervention, actually you are asking to model to correct it. So every time that intervention, obviously a costlier one, to make your model to answer in a correct way, right? So
I would not say completely costly. I would say the latency would be high in order to conclude the
latency,
solution.
means, my perspective is that when the human annotators is not human annotators are annotating the data, this is also one of costlier one. But if you're actually taking one human being to interact during this process, then definitely one manpower is required, right? From that perspective, I'm telling it is costlier one.
Yeah.
Okay. Another one uh, means apart from this chain of thoughts and zero shot and few shot, how much these models, this current state of models, all those models,
Yes.
you are actually handling the many different, we are currently handling the many different models. Now, in this particular context, how much these models are able to solve the problem of complex mathematical problems, you can say. Let's say, for example, calculus and many more, which require a very good amount of knowledge of mathematics and
Yeah.
reasoning. Okay, from that perspective, how much they are capable?
They're pretty much capable, because now if we are considering GPT, for example,
Hmm.
when we are giving a complex mathematical statement, like I said, most of the models now, the chatbots, have become agentic. So it's kind of a multi-model thing that is happening. One agent inside GPT is breaking the query into subqueries. One is calculating, one is checking, like
No,
that.
no, I understand. I understand all those things. I am basically going into the deeper. I am basically telling very specific one. Can it solve the problem of differential equation?
Yeah, pretty much. But I would not say 100 out of 100 questions will be solved correctly. But at least 95 plus, we can generally say that the models now are capable enough to answer.
So, in this context, I should definitely ask those who are actually working in this domain, not only the SOHM, but also the others, those who are working in the large language model specifically.
Yeah,
Uh,
right.
uh, they should also try to understand and also figure it out that what are the bottom line, means what are the challenges still in this particular domain have to solve the problems of the uh, difficult mathematics.
Yes, yes.
Calculus is one of them. Another one I should definitely say, that is your linear programming problem or optimization problem, where actually you have the multiple constraints and multiple many different large number of your variables are involved over there. Simultaneous linear equations, nonlinear equation, integer linear programming, and so many other things. Are they able to solve, like game theory? Are they able to solve? If this is actually the thing, then there is a huge growth of this large language model, and that can be used in the other directions. Okay. So this is also very important one.
Yes.
I think definitely the other people also might be agree with me and have some other questions also. I ask other to ask the question in this direction.
Actually, I have a doubt. In PS or PS Plus model,
Yes.
is the improvement is coming from the prompt itself, or simply using a longer prompt? Means you just send the problem, a mathematical problem, you just send it to the model and it gives the answer, or
I'm telling you.
it would be
I'm telling
better
you.
if the prompt would be longer, explaining how the steps should be taken and all.
Yeah. So let's consider let's say you have a problem calculating the area of a rectangle. The problem is given. Okay, but you think you see the problem is a bit difficult, because either the length or the breadth, something is not given. We have to find out that, then we have to calculate the area. Let us consider it like that. So first your problem should be, uh, first your plan should be, what are the things given to me? Then you need to plan what are the things I require for calculating the area. Then then you find out which one is missing, which one I need to find out. Then you find that out, and finally you apply the formula, and then you calculate the area of the rectangle. So this is how your plan should be. Chain of thought. What happens is you start directly solving the problem. You don't think anything that comes to you. Just start doing anything that comes to your mind. PS, if you follow PS, you are planning this out in your mind. But while solving, if you get something like a difficult calculation, I'm not saying the math, if you get a difficult calculation, then you might have planned some steps ahead, you forget it instantly. So this is how another failure might occur. This is how plan and solve was working. In plan and solve plus, what you do is you devise a plan, and then you write down important steps which you think might be important in the future steps coming up. Steps or variables, like I found out the length of this rectangle, you write it down that the length variable is this one. So in case you are getting a complex calculation, you don't forget. So this is how the plan and solve thing is actually improving. And I again said that plan and solve is not 100% solving the problem like the author said, but yeah, it's drastically improved.
Okay.
Okay. And one more thing, in all the models, either it is COT, PS, or PS plus, we have seen that the semantic errors are not getting reduced significantly, like
Yeah.
the mathematical and other
Semantic errors
errors.
are different. Semantics come from how you are giving the prompt, depends on the English language, depends on the model's embeddings. So these things are the future scope. This is not the problem of the model, but the problem of the data or the tokenizer or the embedding models which has been used for feeding the data inside the model.
And what if we can develop some mechanism that can solve this problem? Like if we tell that model that we are doing this work in the perspective of that work, and then we are asking any question, then it might give correct results.
Um, do you just repeat once?
Uh, Suppose we are doing some research, and the terms which we are using in that one is in terms of cyber, in perspective of cybersecurity. We have already mentioned that we are doing it in perspective of cybersecurity, and then we are asking some questions. Then is it possible that it will reduce the errors considering some terms out of cybersecurity and all?
The thing is, if you are telling the model, if you are like specifying a domain, that you are forcing the model to think in one direction of that domain only, but it completely
Yes.
does not solve the problem of semantics. Like I said, semantics goes down deep inside where vector representations come. So the semantic meanings are being found inside models with mathematics itself. So that is a different scope. This paper discusses how improving the prompt will drastically help improve solutions. The way a model plans or concludes to an answer.
What I have understood from this particular paper and what exactly you were telling right over here, that is actually related to that means, planning and then solving the problem. Isn't
Yes.
that right?
Yes.
So that means LLM is capable to do that, capable to do the better work, not the 100% correct one, what exactly you are claiming in, and the paper also claiming. From that perspective, the planning and the means creation of chain of thought is very important to
Yes.
make them particular model to understand and grasp that particular entire reasoning method by which it would be reasoning, and it
Yes.
might be giving a better result or better than compared to the other one. That is.
Yes.
Now the scenario for this particular large language model, this is actually that become a one thing which is very like a very handy thing for the common people. It's the day by day it's going to be that one. And so now what I'm telling that when the social media was introduced, the with the people started doing the chats in Orkut. From that moment to when actually the Facebook came and the picture sharing and all others came, the thing was very popular and becomes the popularity reached to the common people, not the tech savvy people. Right. Now here, I'm basically getting the large language model, though it was a very technical one, and the chain of thought. What exactly you were telling? This is the thing for those who are technically sound people. They can actually use and do that particular, right? Now, for the layman, those who do not have that knowledge, those who do not have that level knowledge or capability to make your model capable, can't we think in the direction that where this particular chain of thought procedure can be done be in a background and learning from there and developing and understanding their model better way so that it can serve the common people, not only the technical people. And if this is being done, I don't know whether it is right now it's possible or not. If this is being done, in then only the large language model can reach to the common people hand. Means I'm telling this will be very handy that people will be using.
So
Right.
what you are wanting to say is a layman user doesn't know about chain of thought or like
Yes.
the
How
model
they
things.
will understand that
But
what exactly it needs to tell to prepare your model.
yeah, so the thing is, like I said, now if they're using any chatbot, GPT, Grok, anything, they have mostly shifted to agentic AI. The query does not stop there. An agent is there to always transform the query multiple times. Like for example, if you are doing some vibe coding, like mostly at times I do, if I don't understand the problem statement, I try to tell the model that this is the things that I have heard, this is what I got to know, but I am not completely confident about the topic they are discussing. So the model now, after giving the answer, or like model actually gets an understanding and explains me that this is the problem that was being discussed. So it derives its knowledge from its knowledge base, and that is possible because the agents inside are working. It is transforming the query, it is rewriting the query, all are happening within, and the proper query is getting inside another agent who is producing the answer. So it's not that the layman user's query directly is going inside the model. Many agents are there which are checking, rewriting the queries, everything is being happening inside.
That means what you are telling that the task, what exactly you are telling to do, that can be done, and that is also being done at some extent by the agent.
Yes.
Right. Okay.
Yes.
Fine.
This paper
Now,
is from 2023. So after that, there has been a huge research work that
in the
has
current scenario, you are telling that that is actually unavailable.
Yeah.
Okay. Fine. Fine. Now, now my another concern that now we are taking everything. If it is as it is in a common man hand, then now it become a handy one. The thing is, LLM is in the hand of those who are actually doing the codings. What you are telling, the vibe codings, they have the accessibility of that one. Those who are writing some particular articles, they have also that. Okay.
Yes.
And also the people, those who are doing some kind of computation, mathematical work, all those. Now, how this particular means, is there some specific model development is there which are actually for this mathematical computation? Someone is for specific generation of aesthetic or your artistic things. Like that, like say for example words, story, and for that thing that model is much more better, or for doing the mathematical work some other models are actually there. Is there any variation, or one model can be modified?
From my knowledge or whatever, at least I found out, GPT and Claude, these two are the best LLMs till now that can solve kind of almost every domain like problems, being it rewriting papers, journals or articles, being it solving mathematics. And in terms of code, Claude beats GPT.
Okay. So I came across one particular point that some of the mathematical things still not be solvable, and people are not, this LLM is not able to solve right now also. Like what exactly I was telling, that the difficult calculus problems are not been able to they are not able to solve this one. And also some this operation research and optimization technique, which includes the linear programming, your linear programming problems, and all those game theories are not able to solve at this moment too. Okay.
Mm,
So is there anyone to ask the question? Okay, so I hand over to the Bhanu to conclude the session.
Yeah, thank you, sir. Thank you, Soham, for the insightful presentation, for the clearing, explaining the key ideas which can behind the plan and solve promptings. The discussion actually highlighted how structured planning can significantly improve the reasoning capabilities of large language models. We appreciate the effort. Thank you, all participants, for active engagement. I would request everyone to fill the attendance. The link will be shared in the group shortly. Have a great day, everyone. Thank you.
And also, Bhanu, go for the announcement for the next day's presentation. Next
Yeah.
week, we
As
have
for
a
the
invited.
next week, we have a invited speaker. So all of you are requested to attend that session. Devashish, can you share the details of the speaker? Devashish, are you there?
I think I
Uh,
can share also. There was, if you do not have that, I can share. The next week on 27th, 27th, the
June.
invited talk will be there. The speaker from IIT BHU, he's right now completing his PhD. Uh, mm, his area of interest is specifically energy sector, sustainable energy. So we in our group is now going to collaborate with IIT BHU, that lab. And with this talk, then definitely we'll understand that how our group and their group will be able to connect, and how these sustainable energy sectors problems, computational problems, can be solved from our expertise. Okay. So with this note, I thank the speaker and all the attendant for this particular today's session. Thank you very much, and I close the session right over here. Okay, thank you.